Okay, let's talk one prop z-test or one proportion z-test, and we're going to start that off by talking about a trial. In a trial, we always assume that you're innocent, and we're trying to show that you assume innocent. We're trying to show that you're guilty. Okay, that's our normal order of operations in a court of law. And the question is, how do we show that someone's guilty? Because typically the district attorney is only going to press charges and take it to court if the district attorney has evidence of guilt. So then we produce evidence, and that evidence is used to send to the jury, and the jury decides, hey, do we have evidence to say that they're guilty or not? Oops. Okay, so after that it goes to the jury, deliberates, and the jury makes one of two decisions. We say the defendant is guilty or not guilty. Okay, now what has to happen for the defendant to say that they're guilty? We say beyond the evidence has to be beyond a reasonable doubt, right? And if they're not guilty, that just means, hey, we don't have evidence beyond a reasonable doubt. We say you're not guilty. Now, is that the same as saying you're innocent? And the answer is no. Not guilty just means you still might well be guilty. We just don't have enough evidence. We don't have evidence beyond a reasonable doubt to say you're guilty. Okay, so it's a fine line there. But we do the same thing with in the real world outside of the trial situation. We'll do things like this. Okay. You say, oops, getting all sorts of extra stuff on here. Suppose, let's come over here. Suppose you say 40% of Americans have a student loan. Okay. I think it's less. Okay, so how am I going to convince you that it's less, or convince anybody that it's less? Well, we're going to do what's called a hypothesis test. Okay. I think my wrist is leaning on something that's making it not do that. A hypothesis test is used to see if we have evidence that less than 40% have student loans. Okay, so we're going to do what is called a one proportion z-test. And we're going to assume, first of all, we're going to assume that P equals 40.4, where P equals the proportion of Americans with a student loan. Okay, and we call that H0, that's our null hypothesis, and HA is the alternative hypothesis. I think it's less, right? We'll get this figured out here. I think it's less than 40. Now, this right here we called the null hypothesis. And this is what we assume is true. The alternative hypothesis, that's what we want to show is true. That's our goal. Okay. Well, let's take a look at this. Leave some space here. I'm going to come back and fill in some space here. And so we're going to look at the p hat distribution again. That's my distribution of all my samples. So again, all of my samples. So the mu sub p hat is 0.4. That's the center. And standard deviation is sigma sub p hat. It's the square root of, right, pq over n. Square root of 0.4 times 0.6 over n. I don't know what n is yet. We'll leave it at that. Okay. So what this p hat distribution is, just to remind you, is if I take a sample, I can take any sample, and let's actually use this. Let's take samples of size 1000. So that would make this down here 1000. So if I take a sample of size 1000, it could be there. It might be 41%, it might be 39%, it might be 38%, it might be 40.01%, it might be right on 40%, but it's going to bounce around 40%, right? If the true population, the proportion of Americans with a student loan is 40%, and that's what we're assuming is true, just like we assume you're innocent until guilty, until we find you guilty. So I want to try to convince you that P is actually less than 40%. Well, how am I going to do that? Well, I got to provide evidence, right? That's the evidence here. So what evidence do I have? I don't have any evidence right now, but suppose I take a random sample and I got 370 out of 1,000 have a student loan. Okay, and that would be 37%. Okay, so there's my sample. We call that p hat equals 0.37. So my sample is down here at 37%. 0.37. Okay, so now the question is that evidence? Well, it's less than 40. Is that good enough? The question that we're really asking right now is, could the proportion, actually, let me write that a different way. If P equals 40%, how likely is it that I get a sample of 37, by chance? Or is there a reason why? Okay, so let's investigate that. If the population is 40%, this is 40 right in the middle, okay? How likely is it that I get a sample of 37% by chance? Well, since this is a normal curve, why is it normal? Because NP is 1,000 times 0.4 is 400, is bigger than 10, and NQ, which is 1,000 times 0.6, which is 600, is greater than 10. Remember, NP and NQ have to be bigger than 10 for this to be normal. So if this is normal, we can actually figure out how likely is it that I get 37% or less, right? So let's actually calculate that. The probability that P hat is less than or equal to 0.37. I can do that because I have a normal distribution here. So I can actually find the z-score and do 0.37 minus 0.40 over the standard deviation, this guy. 0.4 times 0.6 over 1,000. And I can calculate that z-score, which I will do right here. And I get negative 1.94. So that tells me that this point here is almost 2 standard deviations below the mean. Okay, almost 2 standard deviations below the mean. So that's pretty far away, isn't it? In fact, let's actually quantify that further. Let's find this area. This area is, if I look it up on my table, it's 2.6%. That's actually called the p-value. Now, 2.6% chance of getting 37 or smaller, that's not very likely to happen by chance, is it? In fact, when does it become something where I would say, oh, that could happen by chance? Like if this was 12%, I would probably argue, oh, that could happen. Something that happens 12% of the time and it happened, I'm not really surprised. But 2%, yeah, I'm pretty surprised. In fact, my cutoff, and our cutoff typically is 5% unless we say otherwise. And that's called our significance level. Okay, at a 5%, that's my significance level. If it's less than 5, I'm saying it probably didn't happen by chance. Okay, so this is 0.026. And so I'm going to conclude this. I'm going to say, hey, since 0.026 is less than 0.05, I don't think it happened by chance. So the question is, why did it happen? Well, it happened because P isn't really 40. P is actually less than 40. P is like 39 or 38. So since 0.026 is less than 5, I have evidence that the proportion of Americans with a student loan is under, or I should say it's less than. Let's use is less than 0.40. Okay, so this is basically the same thing we do on a trial. This is my beyond a reasonable doubt, if you will. That's my criteria for saying, yeah, it didn't happen by chance. Okay. And this is my hypothesis test. Okay. So this is my deal. So I've got step 1. Let me try to number this here. Oops. Step 1 is me naming the test and defining my variables. Step 2 are my conditions. I need to know that this is normal for this to work. And in order for that to be normal, I have to have 2 conditions that we're looking at. It has to be a random sample. And 2, NP has to be bigger than 10, and NQ has to be bigger than 10. That's my second step. My third step is my calculations here. And my fourth step is my conclusion. And what we've said in class is we've named those steps. We named, or I should just say name the test. Name and hypothesis. Second one is our conditions. Third one is what we call the mechanics. And the fourth one is what we call our conclusion. Okay, so those are our 4 steps in a 1 proportion Z test. All right, hope that helps. See you in class.